Hello, dear students. Welcome to our new setup, and today we are going to discuss alkanes, their method of preparations, and chemical properties. Let's discuss what are alkanes. The word alkane is derived from Latin terminology, which is param, offinis, and param means little, and offinis means affinity. So, alkanes are the compounds with little affinity. They are also called as saturated hydrocarbons. And why they are called as saturated hydrocarbons? Because their carbon atom is saturated with hydrogen atom, and this carbon to hydrogen bond has least reactivity. So we will see in reactivity of alkanes that they usually need high temperature and harsh conditions to react further. Their general formula is CnH2n plus 2. Next, we are going to discuss method of preparation of alkanes. The first method for the preparation of alkane is hydrogenation of alkenes, and this hydrogenation of alkenes takes place in the presence of hydrogen molecule, and the hydrogenation needs high temperature, almost 200 degrees Celsius to 300 degrees Celsius, and it also requires catalysts such as nickel platinum or palladium. And in the presence of this catalyst, alkenes react with hydrogen molecule in the presence of nickel and high temperature and give addition product which is alkane. Hence, you can say that this hydrogen molecule actually comprised of two hydrogen atoms, and among them, one hydrogen atom will go to each of the carbon atoms around the double bond. And the second method for the preparation of alkane is reduction of alkyl halides. Alkyl halides undergo reduction with nascent hydrogen and give rise to alkanes. Let's take a look at reduction of alkyl halide. So the general formula for alkyl halide is Rx, and we will write nascent hydrogen as this. So it will give rise to alkanes RH plus HX. As you can see here, the two hydrogen atoms are appearing in product. So the nascent hydrogen, we would write 2 with nascent hydrogen. For example, if we have an alkyl halide as methyl chloride and it will react with two nascent hydrogen atoms, it would give rise to methane CH4 with the release of HCl. So this was methyl chloride, and we had nascent hydrogen, which is atomic hydrogen, and it would give rise to methane plus hydrochloric acid. The third method is decarboxylation of monocarboxylic acid. When a sodium salt of monocarboxylic acid is heated strongly with soda lime, the molecule of carbon dioxide is split off in the form of carbonates and alkane is formed. You will notice that the product in this reaction contain one carbon atom less than the original. Decarboxylation of salt of monocarboxylic acid. Now you know that monocarboxylic acid can be any compound with COH group, and it can form salt with any metal ion. Let's suppose we have Na plus. So the salt will look like this, which means R single bond O negative Na plus. So upon decarboxylation of this salt, we will get alkanes. For example, R single bond C double bond O negative Na plus in the presence of sodium hydroxide and calcium oxide are combined with H to give rise to alkane, and we get sodium carbonate Na2CO3. Now this hydrogen atom actually comes from here, and this sodium and oxygen will combine with the remaining portion to give rise to sodium carbonate. Remember that decarboxylation takes place in the presence of soda lime, which is calcium oxide and sodium hydroxide. The fourth method is hydrolysis of Grignard reagent, and it belongs to the chemical class of organometallic compound. So, upon hydrolysis, these Grignard reagents give rise to alkanes and byproducts. Hydrolysis of Grignard reagent. Now the formula of Grignard reagent is RMgX, and upon hydrolysis it gives rise to alkanes with byproduct. So this one is Grignard reagent, and here we have water molecule, and it gives rise to alkanes and byproduct. The fifth method is Wirtz synthesis. High alkanes are produced by treating alkyl halide with sodium metal and heating it strongly. The molecules of alkyl halide lose their halogen atom in the form of salt. For example, sodium chloride or sodium halide. This usually produce symmetrical alkanes of R prime type, and they usually have even number of carbon atom. Wirtz synthesis. It is used for production of symmetrical alkanes which is used for producing higher alkanes. Now these symmetrical alkanes are of RR prime type, which means that the number of carbon atom on one side will be equal to the number of carbon atom on the other side. Reaction take place when alkyl halides are treated with sodium metal, and the process takes place in the presence of dry ether solution. Let's take a look at its reaction. We have two molecules of alkyl halide as Rx, and they will react with two sodium metal atom, and it gives rise to RR plus NaX. Now the number of sodium atoms are 2, so we will say that two molecules of sodium chloride will form. So this one is alkyl halide, and here we have sodium metal, and it gives rise to symmetrical alkane and sal.